Time-appropriate greetings, everyone, and welcome back. Let's learn today how to do future value computations using Microsoft Excel. Suppose that we are offered an opportunity to invest in a high-risk portfolio which offers 6% annual return compounded monthly. If we invest $10,000 right now, then what is the future value of this investment in 10 years? The annual rate is 6%. The number of years is 10. The number of periods per year is 12. We can now compute the parameters required to compute the future value. The per period rate R is equal to the annual rate divided by the number of periods per year. The number of periods is N and is given by the number of years times the number of periods per year. The formula for future value is the present value times 1 plus r to the n. Note that the circumflex here is used for exponentiation, 1 plus r to the power of n. We can use cell references to plug in these values and find the future value of this investment. We know that the present value is $10,000, that's what we have today, and the future value then is given by the present value times 1 plus the rate, r, to the power of n, the number of periods. PV times 1 plus r to the power of n. $18,193.97. If I invest $10,000 right now, in 10 years, if I have this thing giving me a 6% interest rate compounded monthly, I'll have $18,193.97. Rather than use manual formulas, Excel has built-in functions for future values. The rate is the R, the compounding rate per period. The N per is the number of periods, N. The payment is if you're doing an annuity. In this case, we're not adding anything each month, so this is going to be 0. The present value is the amount of money you start with, and finally, Excel will use all of these data to compute the future value. Let's then do this for our problem. The future value is equal to FV, tab. Notice it will prompt you for all of the parameters here. I click the compounding rate, 0.005. There are 120 periods. The payment is 0, so I'll type a 0 in. And the present value is $10,000. I hit enter, and notice that it created negative $18,193.97, as opposed to what we expected to be positive $18,000. To fix this, go into the formula, make sure you have a negative sign in front of the present value. Basically, we're thinking of taking this money, this $10,000, out of our pocket, which is negative income, and putting it into the investment. So the investment will have a positive future value, $18,193.97. As expected, we got the same answer as using the manual formula, which is always comforting. Let's compute another future value, except this time we're not going to start with any money invested, and we're going to add $1,000 per month. We're going to use all the same periods, over 10 years, same interest rate and everything. The only difference now is that the present value is going to be 0. We're not going to start with anything, and the payment is going to be $1,000. Let's add a cell that contains the $1,000 payment so that we can reference it in our calculation. The future value of this investment then is going to be given by the future value function, where the rate is 0.005, the number of periods is 120, and the payment is 1,000. For the same reason, we need to put a negative sign in front of the 1,000, because we're taking this money out of our pocket, negative income, and we're putting it into the investment. This time, the present value is 0. $163,879.35. If I start with nothing and put $1,000 per month into this investment, I'm going to have $164,000 after 10 years. Notice that in the future value computation, we entered a 0 for the present value. Also notice that the present value has square brackets around it. That means it's optional. If you leave out that argument, the present value defaults to 0. I usually put the 0 in to be explicit because it's more clear that way, but it's up to you. Finally, let's combine these two. Let's say that we start with $10,000 as an investment and we put $1,000 each month into it. Using the same data, we can compute the future value using the future value formula. The rate is still 0.005. The number of periods is still 120. The payment is still the 1,000, remembering to put that negative sign in front of it. And the present value is 10,000, remembering to put the negative sign in front of it. I close my parenthesis and hit enter, and I have $182,073.31. This is how much I'm going to have after 10 years if I start with $10,000 and put $1,000 per month into the account. Notice that $182,073 is the same as $163,879 plus $18,193. Combining the initial investment with the annuity is exactly the same as just adding the two future values. First, just having the initial investment. Second, only having the annuity. It's the same as doing them both in the same formula. Using Excel to compute future values with built-in functions is a great alternative to manual formulas and avoids human error.